Good afternoon, students. So today's topic is instruction set of 80387. As we have already studied the data types and architecture of 80387, now there are 6 types of instruction set. Before proceeding to the instruction set, we must know that total 68 instructions are there other than 80386. Now these all 68 instructions must start from the capital letter F, capital or small, whatever it may be, but it will start from a letter F. F stands for a floating point number, that is nothing but a real number. Yesterday only we have seen that it is real number, it is nothing but a fractional number having a decimal point in it. So now today we will start with the different types of instructions we are having to process the complex mathematical instruction in 80387. So total 6 groups are there: data transfer instructions, arithmetic instructions, compare instructions, transcendental and trigonometric instructions, constant instructions, and the last one is processor control instructions. Today we are going to cover first two groups, that is data transfer instructions and arithmetic instructions. So now we will start with the first type, that is called as data transfer instructions. Now we can have the data transfer in three data types. The first one will be a real data transfer or a integer data transfer, or third one is the packed decimal data transfer. Now as we all know that your 80387 is able to perform operations only on real type of data type. It will not be able to perform the data operations on integer type or any other type. So the first type of data transfer, that is called as the real transfer. In this real transfer we are having 4 types of instructions. Now you can see over here that the first instruction is, here it will be FLD, then FST, then FSTP and F exchange. So for these instructions comes under the real transfer. It means whatever operands we are considering in this, they are real in a data, they are having a data type real. Now we already know that load and store, these are the two opposite operations. So FLD, as we know now, all the instructions will always start from a letter F. So load operation, so the instruction is LD and it will start from a letter F. So the instruction is now known as FLD. That is, the meaning is load real. The next instruction is FST, that is store real. The another third instruction is FSTP, that is store real and then pop. And the last instruction is F exchange, that is exchange the registers between the operands. Now same this load and store instructions we can perform for the integer data type. Now as we know that the 80387 can perform only on the real data type, then if the integer data is there, so you can load the integer data by first converting that integer into the real and then load it on the stack. Now we all know that all the operations of 80387 performs on the register stack, that we have already seen yesterday. It is having total 8 registers starting from R0 to R7. Okay, so whatever instructions we are performing, executing, the operands are loaded onto the stack or they can be stored from the stack. So load and store, these operations are there. So now when I am talking about the instruction FLD, we know when load is there, always we are considering the source, and when store is there, always we are considering the destination. So FLD is there, so you can have a syntax that is FLD and then source. It means that we have to load whatever provided in the source to the top of the stack. Now how many elements are there in a stack, that doesn't matter over. If 0 elements are there, it will be loaded onto the stack, the values given in the source loaded onto the stack, and it will be considered as a top of stack. If FST operation is there, FST will have the destination operand. So we have to pop the top of stack from the stack and it will be stored onto the destination provided. We can see examples later on. So these 4 instructions are there. Then integer transfer is there. So integer load, integer store, and integer store and pop. STP stands for first store it and then pop the top of stack. And the third type of data transfer is packed decimal transfer, that is the BCD. Now here also, as the 80387 is able to perform only on the real data type, first it will convert the packed BCD into the real and then it will perform the load and respective store operation. Now we can see the example over here. See, the first instruction is your FLD instruction. So FLD source, it always first decrements the stack pointer by 1 and then it will perform the load operation. So for example, here you can consider FLD ST of 3. ST of 3 is considered as a source. So it means that whatever contents of ST of 3, that you have to load to the top of stack. Now in every example, the ST stands for the top of stack. No 0, no 1, no 7 is there as a parameter. So only ST, it means that is the top of the stack. So FLD can be with a simple one operand, that is FLD source. It means load that ST of 3's contents onto the top of stack. Same FST operation is there. Now here this ST of 2 is considered as a destination. So we have to copy the top of stack and then copy it to the ST of 2 that is provided into the destination and increment the stack pointer. For the load operation, we are decrementing the stack pointer. For the store operation, we are incrementing the stack pointer. Then we are having the integer instruction, integer load. So while performing the integer operation, FILD will be our opcode, and whatever is the parameter or operand provided, we have to first convert it from integer to the real and then load it into the top of the stack. Same we have to perform with the FIST destination. FIST destination will have first, it will pop the content of the top of stack and then it will convert it into the integer and then it will store it onto the given destination. Now while performing the load operation, we are converting the integer value into the real and then we are pushing it onto the stack. For store operation, we are popping the top of stack, which is actually a real value, and then we are converting into integer to store into the given destination. Next instruction is FISTP, that is I, that is the integer, ST means we have to store, and P stands for a pop. It means that first we have to perform the simple FIST operation. FIST operation will be, that is we have to pop the stack element and then convert it into the integer, store it into the given destination. After performing this operation, that is after performing the FIST operation, then pop the element. Pop the element means the top of stack you have to pop. That means ST of 1. After top of stack, ST of 1 will be there. Then ST of 2 will be there. So after popping the top of stack, ST of 1 will be considered as a top of stack. Then for packed BCD data transfer, that is the third type of data transfer, we are having the FBLD, that is same like FILD. Integer load, now here it will be a BCD load. It means we have to perform the load operation, but first convert the given content into the source into the real format and then load it onto the stack. Same like FBLD, we can have FBST, that is store, which is a real number, and we can have another third instruction FBSTP, that is we can store as a real and then pop the top of the stack. Now this is what the first group, that will be your data transfer instruction. So here in data transfer instruction, we can have a real transfer in which 4 instructions are there, integer transfer in which 3 instructions are there, and packed decimal transfer in which